Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem level of nodes. First of all, let us start by understanding the question. What does question say? Given an integer x and an undirected acyclic graph with v number of nodes labeled from 0 to v minus 1 and e number of edges. So basically we are given a graph which is undirected, so the edges do not have a direction. It is acyclic, so there is no cycle present in the graph. It has v number of nodes which are numbered from 0 to v minus 1 and e number of edges. Find the level of the node labeled as x. So we need to tell the level of the node x, and x is given in the input. Level is the minimum number of edges you must travel from node 0 to some target, right? So level is nothing but the number of edges required to travel from node 0 to some node, okay? And we need to find your level of x, which is nothing but number of edges required to travel from node 0 to node x, okay? Or you can also say minimum distance between node 0 and node x. If there doesn't exist such a node that is labeled as x, then we will return minus 1, okay? So if we look at this example, here x is equals to 4, so I need to tell the minimum number of edges required to travel from 0 to 4, that is level of 4, right? So it is nothing but 1 and 2 because I'll travel these two edges, so my answer is 2, okay? You can read the explanation. Similarly, there is second example. You do not need to read input or print anything. Your task is to complete the function node level, which takes two integers v and x denoting the number of vertices and node, and another adjacent list adj as input parameters, and returns the level of node x. If node x isn't present, then return minus 1. The expected time complexity is big O of v and expected auxiliary space is also big O of v, and the constraints are given here. So now if we think about solving this problem, then suppose this is our given graph and x is equals to 3. So I need to find the number of edges required to travel from node 0 to node 3, okay? Or the distance between node 0 and node 3, or the level of 3, right? So what I can do here basically is, see, I can consider weight of each edge as 1 unit, right? So I can consider weight of each edge as 1 unit, right? And now I need to find the minimum distance between node 0 and node 3, where 3 is our x here. So basically now I need to find the minimum distance. So it is converted into minimum distance question. But here the weights of the edges are same. It is 1 for all the edges. So I can apply here BFS, that is nothing but breadth first search starting from node 0, right? So what we do in BFS, first of all, we take two arrays, distance and visited. So here I have 0, 1, 2, 3, 4 and 5. I have these many nodes. So I'll mark distance of all these as infinite, and I'll mark visited as false for all the nodes other than the starting node or root node. I'll mark this visited as true and the distance as 0, because I am starting my traversal from here, right? Now I'll take one queue and insert 0 inside it, okay? That is nothing but the starting node. Now until queue is not empty, I'll pop out the first element from the queue and update the distance of the adjacent nodes of that node if possible, and I'll keep repeating this process until queue is not empty. And whenever I update a distance of any node, I'll push that inside the queue. So now initially I have 0 inside the queue, so I'll pop it out, okay? Let's say I is equals to queue dot front, which is nothing but 0. Now I'll update the distance of the adjacent nodes of 0 if possible. So the adjacent nodes of 0 is 1 and 2, right? So I'll say if let's say x is the adjacent node and I is the current node, right? So I'll check if x is not visited before. If visited of x is false, right, then I'll say distance of x is equals to distance of I plus 1. I'll say q dot push x, and I'll also mark x as visited. Whenever an element is pushed inside the queue, we will mark it as visited, okay? Now understand this. Why are we writing distance of x is equal to distance of I plus 1? Because let us say there is some node I which is, let's say, at a distance d1 from some root node, okay? This is some path, okay? Now there is adjacent node x which is not visited before. So can I say distance of x, that is nothing but distance from the root node up till x, is nothing but distance from root node till I, that is d1 plus 1. So if the distance from 0 to I is d1, my distance from 0 to x will be d1 plus 1. That's why I am writing distance of x equals to distance of I plus 1, right? So here what I'll do, what are the adjacent nodes of 0, 1 and 2, and 1 and 2 both are not visited. So I can say distance of 1 equal to distance of 0 plus 1, that is nothing but 1, and I'll push 1 inside the queue. And I can also say distance of 2, because it is also not visited, is equal to distance of 0 plus 1, that is 1, and I'll push 2 also inside the queue and mark this as true, because whenever I push an element inside the queue, I'll mark it as true, right? Now what is the first element in the queue? 1. So I'll pop it out, so my I will become 1. Okay, I'll keep repeating this process until queue is not empty. So what are the adjacent elements of 1? The adjacent elements of 1 are 0, 3 and 4. But 0 is already visited before, it is marked as true, so we will not update it. I can update the distance of 3 and 4. So distance of 3 will be equal to distance of 1 plus 1. Distance of 1 is 1, so the distance of 3 will become 2. And I'll push it inside the queue and I'll mark it as true. Then distance of 4 equal to distance of 1 plus 1. Distance of 1 is 1, so this will also become 1. I'll mark it as true and I'll push it inside the queue. Right, now I'll pop the top element from the queue, which is nothing but 2. So what are the adjacent elements of 2? 0 and 5, but 0 is already visited, so I cannot update it. So I'll update 5 because it is not visited before. So distance of 5 equal to distance of 2 plus 1. So it is equal to 2 because distance of 2 is 1. I'll mark this as true and push 5 inside the queue. Right, now I'll pop the first element from the queue. It is equal to 3. What are the adjacent elements of 3? 1. But 1 is already visited, so we will not make any changes. Then I'll pop out 4. So what is the adjacent element of 4? 1, but 1 is already visited. So I'll pop out 5. What are the adjacent elements of 5? 2, but 2 is also visited before. So I'll do nothing and my queue becomes empty. So I'll stop here. Okay, and I have my distance array updated. So distance of 0 is 0, distance of 1 is 1, distance of 2 is 1, distance of 3 is 2, distance of 4 is 1, and distance of 5 is 2. What does this denote? This denotes the number of edges required to travel from node 0 to a particular node x. Okay, and here our required was x equals to 3, so my answer will be 2, and that is correct because here the number of edges required to travel from 0 to 3 is how much? 2, so my answer will become 2, right? What would be the time complexity? Time complexity of a BFS is V plus E because we travel each vertex one time and we also need to travel the adjacency list in order to see which elements are adjacent. So that contributes to E. Okay, and what would be the auxiliary space? The auxiliary space here would be big O of V because we take two arrays, distance and visited, which are of size V. Now let's look at its actual implementation. So now if we look at the actual implementation, so first of all I have said that if x is greater than equal to V, then return -1 because it might be possible that x is out of the range, right? Because vertices are from 0 to V minus 1. Then I have taken one distance array of size V, one visited array of size V, that is boolean, and some variables I and j. Initially I have marked all of them visited of I as false and distance of I equal to some big value because practically we cannot store infinite, right? Then I have taken one queue which will be used to apply BFS. Then I have pushed 0 inside the queue, that is the starting element, marked distance of 0 as 0 and marked visited of 0 as true. Now until queue is not empty, take the front element, pop it out, and for all the adjacent elements of that element, if the adjacent element is not visited before, so x is the adjacent element of I, if x is not visited before, then mark distance of x is equal to distance of I plus 1, push x inside the queue and mark visited of x as true, and keep repeating this process until queue is not empty, right? Then if distance of x is equal to 10 to power 8, which was the initial value which we have given, it means that it has not changed. It means that x is not reachable from 0. Okay, the graph may be disconnected between 0 and x. So we will mark distance of x as -1 because in that case we need to return -1. And finally we will return distance of x, which will contain either -1 or some valid value of distance starting from node 0 to node x. Okay, now let's submit this code. Okay, so let's submit it. So we have solved this question successfully. I hope you have understood this solution completely. Thank you.